Welcome. Let's look at part 2 for this unit on polynomials and factoring. We're going to start with essentially just normal distribution like everyone's done before. So we're going to take a monomial and multiply it into the parts of this trinomial. So we're going to use the rules we know about exponents to do that. We're going to have negative 3x times the 2x to the third power. That's the first one of these. And then we're going to add to it that negative 3x times the 7x, the second one. And then we're going to add to it that negative 3x times the negative 3. So what we're doing is this negative 3 times this first one, then the second one, then the third one. Just distribution. So when we do that, we have the negative 3 times the 2 is a negative 6. And that's an x to the first power. And remember that the rules of multiplying variables, you add the exponents if you have the variable the same or the base number the same. It could be a number instead of a variable. So we add the exponents, which means me at x to the fourth, which makes sense because we have 1x here and we have 3x's here. So the 3 doesn't go away there. And that's a total of 4. So this one here could be written as x, x, x. And then there's another x here. So together, that's 4 x's. Then on the next one, we have a negative 3 and a 7, which multiplies to a negative 21. And we have only 2 x's. So x times x is x squared. And on the last one, we have a negative times a negative. So that'll be a positive. 3 times 3 is 9. And then just one single x. And therefore, we have this result. And all we did is we multiplied it into it, multiplied the outside number into it. In the second part of this, we'll actually be going the opposite way. We'll take out the numbers that are common and variables that are common. But for now, let's go back to this and see what we're going to do here. We're going to multiply that to each of the three things. So I'm going to have 5x squared y times 7x cubed plus 5x squared y times 4x plus 5x squared y times negative 6y. It gets repetitive, but that's the point of it, is we're repeating that monomial to each of the parts and distributing it to them. So now we will multiply the 5 times 7 and get a 35. And there's 2 x's here and 3 x's here, which makes 5 x's and only a single y. On the next one, 5 times 4 is 20, and 3 x's and a single y. And the last one, 5 times negative 6 is negative 30, and there's an x squared, but no new x's to put with it. And there's 2 y's, which makes for y squared. And therefore, we have this result with both x's and y's in it. Okay, and that's multiplied in it, and getting those exponents written down. Now, let's also think about one of the lessons from the last unit for this was to name these. Let's take this first one here, and this one is a 4th degree trinomial. And then the next one is a 5th degree. 1, 2, 3 of them also trinomial. So we would name those that way. All right. Oh, I just made a mistake. Let's fix something on here. That is not a degree. And let me emphasize it by doing that. Because what I forgot to mention to everybody is to take this. Let's bring it up here and let's talk about it. We have an x to the 5th power and a y that's to the 1st power. The degree is actually the total of all the exponents of the variables. So that means that even though the x and y are different and we wouldn't put them together with making a 6, the fact is that the total of these exponents comes to 6. So that means the actual correct degree of this is that it is a 6th degree trinomial. Now that you see how easy it is to misplace or mistake one or say it wrong, now you can see how to figure out which way is correct for it. So always look at the total number of variable exponents if you have more than one variable. And that would decide the degree. Now, these next two problems are very similar in concept. What I want you to do is to pause for a moment and do them yourself and then come back to them. And go ahead and do that now. All right, welcome back. Let's take a look at doing these. I have 7x times the first one. 7 times 2 is 14. And then x times 3 x's and 1 makes x to the 4th. Now I'm going to do the 7x times that one. So I have negative 35 and 2 x's. And then I'll do it to this one. So I have 28x. And if you got that, you are correct. And we would name this one as a 4th degree trinomial. Now, on the last one, negative 6xy times this would give me a negative 12, 6 times 2. And this x and these x's make 4 x's, and there's a single y. And then I'm going to do it to this one. So that's negative 42, 1x, but now there's 2 y's in it. And then I'm going to do it to the last one. So again, I'll get a plus this time because of the 2 negatives. And that's 18, and there's no variables, so we only have the variables from the original one, from the monomial on the outside. And now we have this one correct, and we'll name this one, because there's a 1 with that, the 4 and 1 make a 5 to say it's a 5th degree. 5th degree. 1, 2, 3 of these trinomial. All right, not a required thing right now, but still what I was trying to review, make sure people remember how to name them as well. All right, oops, I don't want anything to go away. I want this in yellow so it emphasizes what the correct answer is. The next part of this is the exact opposite. Instead of multiplying in, we are taking out. And this is the first factoring part with polynomials, and an extraordinarily important concept and skill that you need to master in order to continue to do well in math in future years. So what we're going to look at is what things are common to each of all the terms. And here's a method I use that really helps me to remember it. I'm going to put a little line underneath it and act as if I'm dividing by the things that are common. It's easiest to start with the variables. I have 4 x's here and 2 here, but only 1 there. So that means for all 3 of them, only 1 x is currently common in all of them. So now I look at the numbers and I see I have a 6, a 21, and a 9. And I am thinking, well, let's see, what goes into them? 9 does not go into each of those. 6 does not go into each of them. But just a little bit of thinking, and you can realize that 3 goes into each of them. Usually, I would also do it with a negative. And in fact, I need to emphasize that here, that if the leading coefficient is negative, you don't want that negative inside in the result. So that means that you should be putting that negative here and dividing by a negative 3 for each. Only if it's the first one. This one's perfectly okay to be negative there, the middle one. It's the first one that you want that one to end up positive. So now let's go ahead and divide those. Negative 3 into negative 6 leaves a 2, and x goes into x4 with 3 x's left over. And these 2 negatives will make a plus, and 3 goes into 21 7 times. And this x cancels out one of the ones on top, so I have a single x. And here I have, for the last one, a plus and minus. 3 goes into 9 3 times, and the x's cancel out. What I want you to not forget is that you have to put it in parentheses, and the thing that you took out from each of them has to be put in front. So that's negative 3x, and that would be our answer. That's the common factor in front, and then the results of the leftover parts on the inside. Now notice something, negative 3x, right up here, that's what I did here at the beginning, times 2x cubed plus 7x minus 3, and that's what we have here. So this first problem was nothing more than the first problem above, but going backwards now. Okay, let's get this in yellow. So you don't always see the negative that's in front, but now you know what to do if you do have a negative for the first term. You make that negative part of the common factor. This next one, let's take a look at 16, 8x squared, and 12x. Well, first I see that each of them has 1x, so I could take that from all 3 of them. Next, I look at the numbers. I could divide each of them by 2, but there's a bigger number I can divide each of them by. It's not 8. 8 would go into 16, but it wouldn't go into 12. But it does look like I can use a 4 on each one of these. If I did it with a 2, I'd have to do it again afterwards with another 2. So I want to take the largest of the common factors, or what we call LCF. Now we would put that 4x in front and put the results after we divide. 4 goes into 16 4 times. This x cancels out one of the x's above, so it's x squared. 4 goes into 8 twice, and it's negative because one's negative and one's positive. And this x cancels out one of the ones above, so there's only one left. And the last one, there's 3, and no x's because they cancel. And that gives this answer. Very important to recognize that the multiplier must be there. Must be here. Must be here or in front. I'll put in front too. All right. So don't, when you do these, do not forget about those. They're very important to have those there. In front. In fact, it just doesn't, it's not the same. It would be wrong if you didn't include it. There are 2 at the bottom. I want you to take a moment to figure those out yourself. There's a couple of little interesting twists to them each compared to the others. But figure it out. Take a moment to go do it, and then come back, and I will go through them myself. Okay, welcome back. And on this first one, first I could see an x to go into each. Now, I can't divide them all by 2 because they're not all even. There's a 7 here, so that's the smallest one, and nothing goes into 7 except 1 and 7. And 1 and 7, well, 1 works but doesn't change anything. We don't put a 1 in front. 7 doesn't go into 9 or 18, so that means there's only one thing that's common, just the x, nothing but that. You know what? There's nothing wrong with that. Let's just do it with the x going into each of them. It'll be a 3 here, minus 9 and just a single x, and plus 7 because the x do cancel out. And that is all it is. Sometimes you take out a number, just the variable. And so that's what I have here. Other times it would be the opposite. You take a number out but no variable because they wouldn't all have the same variable or combination variable. Okay. Let's see if I can now get this to stay. There, very good. On the next one, well, you should have done, we look at it, it looks like they each have an A, but only one A from them. There's 3 B's here, and an A I'll put there. And there's more B's there, so, but I can only put down underneath the total amount. So an A is in both, and 3 B's are in both. And then there's a 13 here, and it goes into 26 2 times. So therefore, we can take it out as a factor also. So that means my outside is 13ab cubed. And now for this first one, everything cancels. And so you have on top and on the bottom, The cancel doesn't mean 0, it means 1's in place. So what we have is a 1. Something on top of the exact self is 1. Plus 13 goes into 26 twice. The A here takes away one of the A's there, and the B's here take away all but one of the B's. And that would be the solution. So multiplying is something in and taking something out are actually just like inverses. They're the same thing, just opposite. And you want to be very comfortable with both of those, and hopefully you are now. Thank you for watching, and hopefully it's helpful.